Central Europe time. Welcome everybody. As usual, we are here in AGV Network, and today we're gonna have a great technical discussion with two guys that you see there, the pictures, and I will introduce them in a while. But first, before starting to do this, please write me in the chat if you can hear me. Write me where you are, if there is something that is working, is not working. So I need your feedback. So please write in the chat. Okay, Tom, hello, thank you. Nawel, okay, Ben. Well, it's wonderful to see people that I know personally writing in the chat. There is a lot of people that is following all the webinars that I do not know personally, but I know, I feel I know you, so that's a good thing. Roberto, wonderful. Juan, okay. So we have people from North Carolina, from Iran, from Netherlands, so from the States. Always, the community is a worldwide community, so thank you very much for being here. So just in a moment, I will we will start this presentation today. The slides that you are going to see today are going to be shared with you only for those that are waiting until the end. No, I'm joking. We will provide these slides and more information, because we have more technical information that I will share with you after the webinar. So please stay until the end, because there are a lot of things to say and to learn today. What else? You can write in the chat. Hello, Cindy from Boston. You can write in the chat. We will, in this case, we will have a Q&A section at the end if we have time. Otherwise, I will just read your questions and try to pose these questions during the webinar. Okay, so let's present these guys here, because today we are talking about I think it's a trendy topic. It's a very, very interesting topic, and step by step we are arriving there more and more. We are going to talk about mobile robots in outdoor conditions. Okay, so outdoor navigation today. There are a lot of problems in outdoor navigation. There are solutions, and there are ways to afford this. And today we have two companies that are working on this and are providing this solution for the navigation on the outdoors. One thing, we are not going to talk today about safety. Okay, so please do not ask about questions about safety. We can of course answer after the webinar, because today we are only focusing on localization and navigation. Okay, so understand where the vehicles are and where do they have to go. For this, we have Peter from Navitec and José Luis from GIM Robotics. I will, guys, not introduce yourself, because I would forget something. So I leave you do by your own. I think you can do it much better than I can. Please introduce yourself and introduce a small introduction also of your company, and then the show is yours. Start the presentation, okay?
All right. Thanks, Alfredo. Navitec is based in Finland, as some of you may know, but I'm based in the U.S. and the Boston area, and I've been in the mobile robotics industry for I guess over 10 years now, spanning 4 different companies. So looking forward to the discussion today. And we'll do introductions of Navitec and GIM Robotics as part of the presentation.
Wonderful.
Jose.
Jose, okay. Who are you and why you are here today?
Thanks. I'm José Peralta, for the friends here like Alfredo and Peter. And I'm CTO of GIM Robotics, being with the company, so one of the founders, already almost 12 years, providing solutions for mobile work machines, and also now intralogistics. I've been in the robotic business for more than 20 years. And yeah, always loved robots, little machines, and glad to be here.
Great. All right. Well, I'm going to kick things off, and then Jose and I are both going to, kind of talk through different parts of the agenda today. Here's a summary of the topics Jose and I will be covering today. First, I'll do a quick introduction to the GIM and Navitec partnership and solution. Then we'll talk about what we see to be some of the most promising emerging markets for outdoor autonomy. Next, we'll discuss the technical challenges facing outdoor autonomy and how we solve them. That's kind of the meat of the presentation. And then finally, we'll wrap things up with a few success stories, and hopefully we'll leave enough time to answer questions we haven't covered during the discussion. And just a reminder, feel free to post questions in the chat, and then Alfredo, I know you're not shy, so feel free to jump in and ask questions as we go through.
Absolutely.
Okay. All right. So just a little bit of an advertisement, just so you guys know who we are and where we're coming. So Navitec and GIM Robotics are headquartered in Finland, like I said. Both companies actually just outside of Helsinki. We've been around the industry for many years, so some of you may already be aware of Navitec and GIM. The teams have been friends and colleagues forever, and we are literally just right down the street from each other and have lunch together. And I think there are some professors that taught some of the students that are employees now, so it goes back over many, many years. Together, we have today almost 100 robotics engineers between the two companies. So there's a huge amount of intellectual property, a huge amount of talent between the two companies. And we offer what we believe is the world's most advanced software stack for outdoor mobile robotics. Okay, so what does that mean? To just get specific, we offer together a complete software stack. We sell the software as licenses to OEMs and users who are building autonomous vehicles. These vehicles could be forklifts, tuggers, straddle cranes, really whatever. The graphic with the 3 cylinders shows what each company kind of brings to the table in terms of technology. Starting from the bottom, you have the navigation software that controls the wheels and the motors, generates the path plan to get from point A to point B, and decides how best to behave and avoid obstacles along the way. So we call that vehicle control and navigation. So this is kind of Navitec's piece for this puzzle. Localization and perception is a very different trade space in outdoor environments versus indoors. This layer answers the question of where am I and what's around me. And GIM is the market leader in this technology for outdoor settings. And then at the top of the stack, you have fleet management, or the air traffic control for a fleet of vehicles. And Navitec's been in the market for fleet management solutions for AGVs and AMRs for many, many years. So when you bolt it all together, and it is a turnkey solution for outdoor autonomy. Taken all together, the joint solution provides infrastructure-free and all-weather autonomy for both outdoor and outdoor environments. And we'll talk about the differences between outdoor and indoor because they are a little bit different. Some of the key benefits of the solution include support for almost any kind of vehicle type. So it could be a small flatbed, 500 kilograms, or it could be a huge straddle crane, 500 tons. It doesn't matter. We offer advanced fleet management, including support for VDA 5050 and manual vehicles. We have the most advanced outdoor localization technology in the market. And overall, the solution is, and this is really important, it's very cost effective. So we're hardware agnostic, which enables the customer to pick and choose the best hardware for the application. And then we provide all the tooling all the way to calibration and commissioning for deployment. So yeah, it is a total solution. And that was a bit of an advertisement. So let's move on to the next topic in the agenda, which is really just to kind of set the stage. So what are the markets for outdoor mobile robots? Today, Amazon has over 1 million AMRs deployed in their warehouses globally. 1 million. It's amazing. So how many mobile robots are deployed in outdoor environments? Sure, there are a few. There are a lot, but compared to the indoor market, it's a very, very small number. And really, this is the key takeaway from today's webinar. The technology and our solution has reached a stage where outdoor can be easily deployed and developed and commissioned, you know, reliably and robustly. So,
well, Peter,
yeah.
Peter, yeah, you say that it's true that there are, of course, not so many today. We know there are some of them, and we will see videos today. Thanks to because until today it's clear, and we will see also in the presentation that it's not so easy going outdoors. So many tried in the past, and also many failed. So this is why there is a huge opportunity, no? And now we are going to see these industries. But I think that is one of the main trends, as I said at the beginning today, because I receive queries not every day but every week about potential solution suppliers for outdoor yards in many industries. So that I completely agree with you.
Yep, absolutely. So let's take a look at just a few of the markets where we're seeing a lot of activity. This is not all the markets, but it's a few that I think are interesting and fun to talk about. So the first one is what we call the indoor-outdoor market. You know, a big segment we see here is in the industries where the product is manufactured indoors and then stored outdoors. So steel and aluminum fabrication, construction materials are great examples. Pipe manufacturers, they're looking for ways to automate the movement of product from, you know, from the indoor production to outdoor rack storage, like you can see in the, you know, the image on this slide. And there are a lot of examples for other, like, again, I would call it outdoor inventory applications. Another market is just, you know, general manufacturing, where you need to automate the movement of work in progress, basically between buildings and a large production facility. So
you know, Peter, I lost a couple of projects because of this in the past. Some years ago, there was some projects in automotive, and there was the internal loop, everything was fine. The problem was that we had to go to pass from one building to the other. Okay, it was quite long distance. At that time, there was not a real technology, because they started to ask us, of course, the customer, about reliability, etc., etc. So there was not a real technology able to grant this kind of reliability that the customer was asking, and was very, very expensive, if something, you know. So we had, for internal purposes, to install outdoor vehicles, much expensive, that in outdoors was not so reliable. So the project didn't go. So I agree with you. There are a lot of large manufacturing capacities that are whipped between buildings is a huge market.
Definitely. I was in Detroit last week, driving around. You know, you could see the Ford production facilities, GM, and sure, there's that huge building, which is the main production line. But there are always other buildings where material has to come and go, and raw materials coming in. So even in these really sophisticated industries like automotive, there's always some movement between buildings. This is a fun one. So the GSE, or ground support equipment market for airports. This is a big market. It's a market I didn't know much about it a couple of years ago, but the next time you're on a plane, you know, sitting on the tarmac, take a look through the window at all the manual vehicles driving around. It's crazy. There are a lot. So here on the slide, the images, I'm showing just a few examples of the different types. You've got air conditioners, belt loaders, cargo loaders, pushbacks, dollies, baggage tractors. And I actually had 3 slides filled with all the different machines moving around manually at the airport. Baggage tractors will probably be the first to automate. And we're already working with some of the OEMs and airports on trials and pilots. We'll actually show you a video later of an example. Port operations, another natural candidate. You know, you look at this, just in this picture, it's basically a classic cross-docking environment, but instead of pallets, they're moving whole containers. So it's bigger machines, huge machines, big real estate, wide open spaces, challenging weather environments. But I mean, this is basically an outdoor warehouse. So huge potential here. Construction market is another interesting one. Telematics and electrification have been kind of coming into the industry from companies like Caterpillar and John Deere. So that's the recent wave of innovation, and we think actual automation of real work, especially at larger commercial construction sites, is not too far off. Back in this is cool. Back in 1998, Navitec helped pioneer some of the world's first autonomous mining vehicles. 1998, like that long ago, and then we've seen steady growth in this market ever since. Anyway, these, again, like I said, these were just a few examples to give you a sense of how large the market for outdoor autonomy is going to be in the future. So yeah, let's move on to the next topic in the agenda, and we'll dive into
Peter, can I add a couple of applications that I think are also interesting?
Yes.
Agricultural applications for outdoor mobile robots. There is also a big market there. Mainly in the States, because in Europe we have a smaller fields and more complicated regulation. But in the States, I've seen very interesting applications. And another application I think is also military and surveillance. Okay, applications for outdoors are also good markets for mobile robots.
Yeah, and then there's outdoor, last mile delivery robots that you see now already in some of the big cities. So sure. Okay, well, let's move on to the next topic in the agenda is where Jose is going to dive into outdoor navigation challenges and solutions. So over to you, Jose.
Okay, so outdoor navigation challenges. So a bit of a spoiler alert, we have a solution for outdoor navigation, and that solution is all about sensor fusion. So when I talk about challenges here, I would like us to, or you to think about the sensors itself, how difficult it is for the sensors to generate data, or how to interpret the data from the sensors when we are talking about these different situations. For instance, the terrain. So when we go outdoor, we cannot expect anymore that the terrain is flat and is very smooth. So things have kind of a different level. So you go from high to low. So you have steep slopes, or you have some other challenges when you are driving the machine. So first of all, the machine needs to be able to be mechanically built to overcome those. But then we need to be able to also consider those when we are kind of developing a solution for localization. And simple things like just getting the odometry from the vehicle is not as accurate, for instance, as you will get when you are on an off-road machine. So I would like to show a video here that shows a machine driving around outdoors. And if I put it a bit back, can you see the video? Yeah. So this will be a truck doing some material handling transportation on an industrial facility. So where you are loading the truck and then you are unloading the truck in some other way. Things that you can see here, for example, is that, first of all, the dynamics of the vehicle will influence how you gather the data, because the sensors are on top of the cabin there. The cabin moves a lot. The cabin moves with respect to the frame. Also, there is uneven terrain. It's a bit more difficult to do the filtering of the terrain. So these are things that need to be considered when you are developing your solution for off-road. And again, thinking about the sensors, you need to think that the sensors need to cope with this, and also the machine. Other things that we need to consider a part of the terrain is the weather condition. So once
Jose, one question. Guys, you both are in Finland, okay? So I can expect the best of the best about the weather conditions in terms of reliability and testing from you guys, because I have not. for my friends in the south of Spain, but if this solution were developed in the south of Spain, where rains 3 days a year, okay. But working in Finland, I guess you guys has a huge, a great knowledge about this. So it's good that you come from the north of Europe. In this case.
You're completely on spot. So
no, because
Finnish,
no, but I tell you, it's
company,
not, it looks like a joke, but it's not, because also in Italy, where I am, in the north and in the south, is a huge difference because of course the weather, of the fog, the wind, the snow, rain, etc. It's completely different. So
exactly.
if these vehicles and these solutions are developed in a place where is snow and and ice during an important part of the year, is it's a good test. I mean.
Yeah, exactly. So we develop our solutions here, and we go and test outside in our backyard. And our backyard, 4 to 6 months a year, we're gonna have bad weather, so they need to keep working. It's not that we're gonna stop testing because of stuff. And we are considered that Finnish companies are considered like Arctic condition companies. So when things work with us, so you know that they're gonna work in the worst weather here. And it's part of the things that, again, the sensors that we use for our sensor fusion solution will encounter this difficult condition. So you're gonna have like this type of images in your camera. If you're using cameras, you're gonna have snow, you're gonna have rain, you're gonna have dust, depending on the application that you're using, and you have to cope with it. And for instance, here I can show you a video of our backyard during the winter time, and how the machine look like. If we will have to go here about it. Yeah. So this is our normal winter day. You imagine that is snow coming up on the sensor data, that is snow coming up on the camera if you're using camera, and well, the machine needs to drive on these conditions, and your localization needs to kind of remains accurate and remains reliable. So
I can imagine that in this case it also depends on the sensor quality, no? Because I don't know if there is already some kind of filtering of these situations already in the sensor itself.
So this is what I can explain a little bit later on when we're talking about the algorithm. There is a natural filtering that's based on algorithm that interprets the information of the sensor as a probabilistic output. So kind of naturally filters this, that will be noise when you're comparing it with respect to the map. But of course, the sensors itself, if they're better quality, if you have more channels, if you have more points, then you can perceive more the environment. But there is a level of filtering that you need to do anyway from the data. That said, weather, something, difficulty, again, outside, you cannot control it, you have to kind of cope with it. Other things is the operation area. So outdoors, there are much more larger distances. So there might be places where you have very little features. So in those places, usually GNSS works, but sometimes you might have to cope without GNSS. So you need to find a way to combine between the capabilities of GNSS and also the environment features. Sometimes you might be outdoors, but they are very close to walls. So then the GNSS doesn't work very well. So you might have reflections, and the quality of the GNSS might be deteriorated. And also it might be cases where actually the signal GNSS is jammed or spoofed. Nowadays we are seeing those more and more.
Correct me if I'm wrong, Jose. But not only walls, but also, for example, metallic structures like cranes and other things are somehow disturbing the GNSS signal, no?
Yeah, so usually you have a bit more reflection on those environments, and especially in ports, terminal ports. If you're kind of very close in a narrow alleys between container terminals, it's very difficult to get a very accurate localization, just GNSS based. There is alternatives for localization solutions, we're going to discuss a bit later, but just wanted to highlight that these are problems that you have to find a combination of sensor information to provide you the best output. Another source of problems is actually just the indoor and outdoor transitions. So in indoor, you might be using your map-based localization, and outdoor you're using a GNSS localization, but they are not easy to combine if you don't have a very accurate timing and synchronization. You don't want jumps. So usually when you're just acquiring a GNSS signal, you don't have the best quality at the beginning, so you cannot just immediately trust a GNSS signal. And also when you're getting a bit too far away from features, you might not rely that much anymore to the features or to the environment, and you have to switch to GNSS. All those switchings between modalities and between sensors need to be very well handled, so you don't have kind of a degradation on your output and your positioning. Yeah. Then also there is the dynamic. So in indoor, generally you can control a little bit more the environment. That might be dynamic, and there are places that are quite dynamic, and I can show an example there. But usually outdoor, that is a bit more uncontrolled way. So there might be cars parked, there might be a place where there is an interchange between materials, and there might be very places where there is high dynamic things happening there. So our solution also copes with that, but it's something that you need to be aware that your solution needs to cope with how the environment changes.
When you say dynamic, you mean that you have a map, and for your robot is that map, and then the day after you go there, this map has changed. This is what you mean by dynamic, because the environment is changed because new obstacles, things
Exactly.
that have moved. This is what you mean.
Exactly. So here I have a bit of an example. It's indoor, but you can imagine the same thing happening outdoor. So this is an environment where it has not been prepared for automation. So all the features that you will be able to see, they are the pallets, and they are going to be moved. So this environment is going to change a lot.
I told you this is a nightmare for an AGV.
Yeah. But this is something that
when I saw this video, I imagined the AGV mapping this, and the day after, half of these pallets are not there anymore. So
yeah, but as an end customer, you will like that if you are using this first as your location place, you don't want to completely change it.
No, of course.
So you would like to more or less use the same environment, but then adapt, and then your localization. In this case, I'm a bit going ahead, but what we use is the more static part of this environment. So there is a lot of information in the ceiling. There is some information also from the wall and actually the floor. So those remain constant, and then we allocate places which are the dynamic parts, and we don't use it for the localization. So we don't use that information coming from the sensors to register against the map. So we position those as dynamic obstacles, and then that area is not used to compute the information from the sensor. But yeah, so those are all the challenges you need to consider, and I imagine that has been kind of a bit making it a bit scary to get outdoors. But what we want to communicate here is that we have done it. We have done it into those different environments. You have seen videos, both outdoor, difficult terrains, weather conditions, different changing environments, and then the next part is kind of showing how a bit of a technology works and some examples. And I hand it over to you, Peter.
Yeah, and that was great, Jose. I'll add like just another point, which is the platform for localization, all that technology, it's able to do it cost effectively and not require a massive amount of compute. You know, in the autonomous car market or robo-taxi market, if you look in the back of those vehicles, there is like a suitcase of, you know, NVIDIA GPUs, and the solution that we have can run on just a regular IPC, so it's very cost effective as well. So Jose covered kind of the challenges as it relates to localization, and that's really one of the toughest parts. But for sure, there are lots of considerations when it comes to navigation itself and fleet management too. So in terms of overall vehicle design, you know, at a basic level, there's no difference between indoor and outdoor when it comes to navigation. But obviously everything needs to function and be rated for outdoor duty, in some cases for both indoor and outdoor, like Jose mentioned. We see a lot of customers, at least initially, try to retrofit existing manual vehicles And this definitely makes sense for prototypes and pilots for sure, but it can be challenging. So hydraulic steering, for example, is quite sloppy and difficult to automate. Take an existing vehicle and try to find a space for the LiDARs so they don't get clipped off when the machine is moving around buildings. You need to find space for other navigation hardware for the IPC. And then, once you start hacking into the vehicle, there's a very good chance that you're going to avoid the manufacturer's warranty if you're an end user trying to do the automation by yourself.
Peter, but today, what is the situation as far as you see in the market from your customers or people that is asking you? Are OEMs more using manual vehicles and trying to automate them, or they are going from the beginning into an automated solution, not using a manual base? What is the trend? What do you think?
I think it depends on the market. So, for outdoor delivery robots, they invented that stuff from the ground up. When it comes to the markets that, Alfredo, your viewers are most accustomed to, logistics and material handling, yes. I would say there, for the most part, people are starting by retrofitting existing forklifts or existing AGVs. And yeah, so that is completely doable, but some of the issues that I mentioned need to be considered up front, because it's not as easy as it looks.
Well, I was thinking about my own question, and in fact, also depends a lot on the type of vehicle. For example, platforms cannot be already from the manual, but tow tractors, for example, we saw in the airport that you said that they are typically based on a manual one.
Yeah.
Correct.
I can add a bit there that the experience we have got from the other side, that then customers like mine operators or things that have asked us to, can you retrofit this truck? And it's okay, yeah, but kind of financially it would be better to associate with an OEM that already has a drive-by-wire truck.
Yeah, Jose, is a politically correct yes.
Yeah. It's and we can do it, and that's going to be a bit expensive.
Oh, yeah, sure.
But it would be better that kind of the whole value chain understand that's the most efficient way to tackle this.
So we can go either way, but it's important to understand when you're doing a retrofit, it's not always going to save you time or money.
Mm-hmm. Okay.
Okay. Well, what about the fleet manager? So most of the technology around the fleet manager is relevant for both indoor and outdoor traffic management, mission management, all that stuff stays the same. There are some exceptions. A big consideration is wireless connectivity. Wi-Fi, as you would expect, it really doesn't work that well outdoors, at least not consistently 365, all different weather conditions. So we find that 5G and cellular is always going to be a better approach. The fleet manager, just like in logistics, it's got to integrate with the supervisory entity. The end user requires, similar to what an MES or WCS would be in logistics. And those systems can be very different from what we're used to seeing in our market. So, in baggage handling automation, for example, the fleet manager needs to connect and be managed by the airport's baggage handling control system. And these are big, monolithic software platforms that seem to be homegrown from each airport has got their own custom thing. So you need to be able to account for that. There are unique use cases, and there's going to be operational logic that's going to be different from indoors versus outdoors. So you've got to make sure the fleet manager is flexible enough to enable some of those different use cases. But for the most part,
Peter, if I understand, the main problem of the fleet manager is the connectivity itself, not the fleet manager itself. Because for you, correct me if I'm wrong, you don't care if it is outdoor or indoors. You can manage a fleet of vehicles wherever they are. The problem is in outdoors that we have the connection issues with the Wi-Fi or whatever it is. No, is it correct?
I would say I think that the connectivity is solvable with 5G, for example. You just need to account for it and architect a solution for the environment. So it is a challenge, but it's easily solvable. Integrating with the supervisor or the enterprise system, I would say that's probably more of a challenge, because those systems don't necessarily have APIs, you know, like we're used to with MES and WCS systems. So connecting to them and operating alongside with them from a fleet management perspective, I would say is actually the more challenging issue.
Another question about the fleet manager. We could have vehicles that are indoor, outdoors, using 3D navigation or 3D LiDAR that we will see in the next slides, or 2D or other types of localization. Is your fleet manager able to manage these different types of vehicles and localization and navigation technologies, because the navigation is done by you. But is your fleet manager able to manage this?
Yeah, absolutely, and it's just like indoor. So in an indoor environment using VDA 5050, there are different vehicle manufacturers with different localization and maps. And so with VDA 5050, for example, you can abstract that at the fleet management level, and the same thing for outdoor. So we can support any kind of vehicle. And even manual vehicles. So if you want to bring in the manual driven vehicles like man-driven forklifts into the fleet manager, we can do that as well. So you can put RTLS trackers on the human driven vehicles and have all that position data fed into the fleet manager and taken into account, you know, when it comes to traffic management, for example.
Okay, wonderful.
Okay, well, let's move on. I want to be sensitive to time. So, Jose, I'm going to hand it over to you next, because you're going to we've talked about the challenges. So now we're going to talk about how we solve some of these challenges.
Yes, please, guys, because until now we only spoke about problems. It's not good.
Yes, exactly.
We have to provide some solution to the audience.
Yeah. Always the problems first, then solution. But yeah, so to the solutions. So the localization methods that we have seen until now for outdoors. So there has been solutions there, and they're still being used, and they have their pros and cons. And that's what I'm trying to explain here, and then what we are using. So there is still the old technology, or first technology about wires and some sort of magnetic tapes or transducers, tags that can still be used. And I think they are heavily used also in ports and terminals. But it requires a lot of infrastructure and work. So you need to drill them, you need to put them there, and then they need to be maintained. And they are quite static. You have the GNSS, you have the RTK GNSS technology. It can give you centimeter level accuracy, but it has the problem. So it's rarely 100% coverage, and there are places where, depending on the latitude or depending on the environment, you have quite good possibility of outages. So in the industrial application, what's the most important here is to have the reliability and kind of the availability of the solution. You don't want to stop. You don't want to stop the production. You don't want to stop a mining operation. It will cost you millions. So the problem with the GPS is it's very good, but it has the tendencies of not working in all the areas, and you can even have solar flares, and then you have to stop your operation from the time that it goes. It's definitely a very good sensor to have. We use it in our package if it's available, but sometimes it cannot be used in all applications. And then we have some other natural feature localizations. The 2D LiDARs, which are intensively used in indoors. Sometimes they work outdoors if you go very close to the walls and from very small distances. But here the problem, and you can see from the pictures, is that you have very little information about the environment. So the middle picture is, for instance, an indoor area, and the left is how you can see it in 2D, and the right is going to see in 3D. You can see obviously there that is much more information, and that the same happens outdoors. And the difficulty with outdoors as well is that the features are a bit further away. So you can even have 100 meters from one wall to another wall, or from a pole to another pole. So it's much better if you have a 3D LiDAR. If there are more channels, the better. And if there's more distance, the better. Cameras have always been kind of the promise, the future, when it comes, but they do have difficulties with the lighting conditions, with the weather conditions, and also with the setup. So it's quite difficult to tune camera-based feature localization solution to work reliably and robustly, and also to set up relatively quickly. And also, there is now coming the radars, that is especially the 4D radars. They are very promising, but it's still the ranging measurements that they bring, it's less accurate than the LiDAR. We can do localization with radars, but in terms of precision and accuracy and robustness, the 3D LiDAR is what we use. So getting to the bottom point here is that we use 3D LiDARs in order to do map-based localization. So we create a map of our environment, and then we localize with the 3D LiDAR. We also do sensor fusion with other sensor information like IMU, GNSS, and odometry. And we fuse all that information to generate the best and most accurate solution for the localization for outdoors. Then, what do we get? We get the best outdoor positioning solution with a combination of 3D LiDAR, and if it's available also RTK GNSS. We can operate both indoor and outdoor, with or without GNSS. Actually, we can work without GNSS. GNSS is good because it gives you a frame of reference that is easy to make and expand maps, but also it provides you a good initialization solution when you are outdoors, when you
so
start.
Jose, correct me again if I'm wrong. If I understand well, you are using your all the 3D information that we receive from the LiDAR, and you can also combine all this information with the GNSS. Okay.
Exactly.
So and then I guess there are also some more sensor fusion with the IMUs and other things, odometry or whatever is in the vehicle. So you are doing all this kind of sensor fusion, but how do you handle this? Do you provide more? You rely more on a technology rather than another, depending on the conditions, or does your technology adapt depending on the moment, or is always the same?
It does. So that's precisely what the sensor fusion do. So it calculates the different covariances and modes between the different sensors, and based on the most accurate information that we have on that precise moment, we then use more reliability on that particular sensor. So whenever you have less features, then we switch for GNSS, and in most of the cases, we try to use as much as possible just the map-based localization. One thing that I would like to explain, so there is this use of the word SLAM and SLAM-based positioning. SLAM's word sometimes is kind of a misuse. SLAM state means simultaneous localization and mapping. And for us, SLAM is a stage of our process, which we use to create the map. But what we actually do, we do map-based position. Once we have the map of the environment, then we localize with that map. We don't need to use SLAM anymore. We are localizing on the map that is already done. Then if the map changes, we adapt to changes, but essentially the map is already created.
And do you have to recreate the map at a given point?
No, so that's the good thing about both our algorithms and also the sensor. So there is so much information from a 3D LiDAR and how you detect the environment, that if certain parts of the environment changes, it doesn't interfere with the positioning system. So you have to change very, very much, and for us not to be able to see the whole environment for starting to degrade. And even when you don't see that much in the environment, you can continue doing sensor fusion based on the other sensors like IMU and odometry and GNSS, and eventually kind of reach back to the registration with the environment and optimize the solution.
I have a question here from Jan. I think it's related to this specific topic, because we say that, of course, we are using a lot of information to be more accurate, more precise. Do you have an idea of course, I understand depends on the vehicle or on other things. Okay, what could be the precision in terms of stop precision of a vehicle that is using your technology?
Very good question. So we have our functional specification, and that may be something that we can discuss in detail later. But our stop ring precision is between plus minus 1-2 centimeters if we are indoors.
Outdoors.
Yeah. So our docking precision, and then kind of the driving precision depending on the speed, but is within centimeter accuracy.
Okay.
And maybe something that we discuss. Everything also depends on the quality of the sensors we have.
Of course. Also on the mechanics of the vehicle also depends. But I mean, there are many variables, I understand. But just to give an idea, I mean.
Just to give an idea, and that's what we wanted to achieve. So something that will be accurate enough in order to enable the solution for outdoor intralogistics, because we get those requirements from the clients, and this is the level of accuracy that we need. This is the level of precision we need, and that's what we are giving here. I would like to maybe go a bit more in detail. That one of our key IPR behind this is what's called normal distribution transformed representation. So this is the way in which how we process the 3D LiDAR information. So I don't know the background of all the attendees, but what the LiDAR does, it's kind of it's measured distances with respect to this origin of the machine. So it's a ranging measurement system, and it generates a point cloud of distances with respect to this machine. So what we do is that we process very efficiently all this information, so this point cloud information. So in robotics, in order to define an environment, it's typical to define in a grid way. So you kind of represent it like a chess mat area, but in 3D, that square is like a voxel, we call it. So it's like a cube. So in order for you to represent a map, what you usually do is you represent if those cubes are occupied or not occupied. And I can show that in that image you can see. So in our way to represent the environment, we further represent how those points fall inside that voxel with normal distributions. So instead of having hundreds of thousands of points that were falling inside that cube, representing each individually, we kind of representing as a normal distribution in 3 dimensions. So instead of having the information of hundreds of thousands of points, we have the information of the parameters of these distributions inside. Maybe I can show a video and you can understand a bit better how that representation happens. I think it's this one. Can you see the video? Yeah.
Yep.
So here I go a bit forward. There was a part where we can see both Navitec representation and our representation. I think that's the part of the map here. It's a better representation. So this is a typical machine which we have kind of incorporated all the sensors, and the machine is driving autonomous. And the top right corner is the full point cloud visualization. That's all the hundreds of thousands of points. And the top left corner is the transformation, the normal distribution transformation of those points. So they are a set of ellipsoids that represent voxels. So
excuse me, Jose, this is what you on the top on the right is what you get from the sensor. You elaborate it and you get the top left.
Yeah, so this is the raw data in the top right, and the top left is how our computers, how our algorithm sees and operates. So it operates in that left realm. So, and the reason I show this is to demonstrate or to show that we do this efficiently. So we don't do point-to-point operation. We do distribution-to-distribution operation. And because the normal distribution can represent the same information with less data, then we can generate bigger voxels. So we don't need, for the same accuracy, we don't need to make voxels of 10 by 10 centimeters. We can actually use 1 meter by 1 meter voxels. So it's less computation for both generating the maps and also do the real-time localization. And real-time localization with LiDARs and ranging sensors is about registration and kind of an iterative approach. So
but
this is made much
Jose,
more.
you said there is less computational demand, okay? But more or less, what is your requirement?
So as Peter was saying, so we can use a normal IPC, and from that IPC, about one core can be used for
one core. So more or less the same we have with other types of navigation, to the navigation.
Exactly.
Okay.
So yeah, without extending me too much, because I know we are having a bit less time, that's our solution. I love this part of tech, explaining the deep tech, but maybe we can then have another session where I can go much more in detail, even in the part of the sensor fusion, which again is using this information for localization and then adding more information about the GNSS and kind of fusing that as well. Another benefit of our solution is that it has been proven across major different environments. So initially we were outside intralogistics, we were more in construction, mining, forestry. And during these 12 years of operation, we have been kind of the off-road. And now with Navitec, the idea is that proving that, bringing that proven technology also for intralogistics. And we have been operating already tens of thousands of kilometers in those. So,
okay,
this is the next part. I give it back to you, Peter, but maybe also mentioning this part. So coming back to what Peter was promoting at the beginning, that is not just a set of different tools, but what we can offer together with Navitec and GIM is an end-to-end delivery tool chain. So we're coming from even the beginning of simulating how to best operate into an intralogistic environment, how many different machines you need to use, to the calibration of the sensor. So we're going to propose how many sensors to use, which sensors to use, and this needs to be calibrated in 6 degrees of freedom.
One question about the sensors, excuse me, Jose. Yeah. Your system is agnostic depending on the sensor, or you work with some types of brands or types of sensors, or you don't care?
Essentially, we don't care. So the algorithm doesn't care about the sensor, but of course, we need to be able to provide you with the functional specifications and tell you this is the performance, the accuracy. And for that, we need to then support one sensor and test with one sensor. Right now, we have tested with a set of sensors, and that's what we kind of showed you.
So in other words, you need a kind of performance rather than a brand or a type of sensor.
Yeah, well, yeah, exactly. So we can use any LiDAR in order to generate a positioning, but because of one might be less accurate than the others, you're gonna experience a bit less performance than the others.
Of course, no, of course, but that is more depends on the LiDAR function. Yeah, I mean, of the performance. I mean,
exactly. Yeah. And also, yeah. But again, so we have this different set of tools in order to deliver a full solution. So from calibration, the sensors, kind of the mapping tools, transferring that mapping to the fleet management system, generating the orders, do the fleet management, and also then remote monitoring the dashboard. That's about it. Peter, back to you.
All right. Very cool stuff, Jose. And yeah, I think especially for OEMs, having a solution that can be, easily commissioned and deployed at customer sites is critical. Calibration, map creation, all of that stuff, even an indoor can be very time consuming. So having tooling and processes that make it easy and repeatable is critical. All right, so we've covered like the main topics of the agenda, but I promised in the beginning before the Q&A we'd take a look at a couple of actual customer examples. So let me queue up a couple of videos here. You were going to say something, Alfredo?
No.
Nope. Okay. All right. So just gonna click through some videos. So this is a very cool machine, or there's a lot of different machines. The company is Sandvik. Sandvik is a very large company based in Sweden, and they're one of the leaders in the mining equipment market, as you can see. And they have like 65% market share in the teleremote and autonomous vehicle industry. So they are one of Navitec's oldest customers, and some of these machines have been in operation since early in the 90s.
Excuse me, Peter. This is going by its own, this stuff?
Yeah, fully.
Okay, excuse me, the low engineering vocabulary here, but it's amazing in the tunnel.
Yeah. Yes. Yeah, it's very cool.
Well, at least you do not have the weather conditions problem.
It's got other challenges. Trust me.
No, of course, all the terrain. I guess there are many other problems, of course. No. I honestly, I never seen this kind of solution underground. Yeah.
So that's a great example. So that was a a very mature and long-standing customer example. This one is a newer customer. Name of the company is Technicar, and this is basically a tugger, for the airport market. It could be used for baggage tugging, for example. We did do a pilot actually at Helsinki Airport, so very difficult environment from a weather perspective. So again, it's not in production yet, but it's very promising, and like I said before, this GSE market is really interesting. All right, and then the last video before we move to the Q&A is a company called Trombia, and Jose, I guess you should probably do this one.
Yeah, so Trombia is a great company we've been having the pleasure to work for many years now, and they have a great technology of cleaning, so the technology for suction, and they previously had a manually driven machine, and because their technology for suction was so energy efficient, and they realized that they could convert their machine into an autonomous machine and still have a full cycle of operation of a day. And that kind of enables it to be applicable commercially and also kind of in these difficult terrains. But they needed support for the conversion, and here we did a bit more than they usually, just putting the sensors and localization. But it has been a great pleasure to work with them, and now these machines are being sold and operating commercially around Europe, and I think in US as well. So it's a cleaning machine that operates in mostly industrial areas. Here shown in a plant in Finland, and amazing work, amazing technology, and show how you can integrate this in different technology of localization in different industries applications as well.
Okay. Wonderful. But excuse me, but is I guess in that environment, dust is also a problem.
Yeah, that dust can accumulate in the sensor. It might be a problem, but again, depending on the level of dust, you can cope, and that's what we have built in the system. So we have different levels of warning and detection when the sensors are covered or where this information not coming enough. And then that raises flag that, okay, you need to stop, or the localization might be compromised.
Okay. No, because there are several questions, but regard more the sensor itself. So then I will pass you all these questions, and then you can answer them by email afterwards, okay? Because they are very specific to the sensors, but the sensors are giving this data, depends on their quality, and then you manage this data. So
there is no way around that. If you don't have information coming from the sensor,
Of course, yeah. Okay, you cannot figure out.
Yeah, but there are different ways to go around it and then to cope with it as much as possible to the left.
There is a question, Jose. What kind of diagnostics do you provide your navigation? You said before about the sensor is covered. What are the diagnostics that you can handle?
Yeah, so we have to build it by layer. So we have first the information that each sensors are providing good quality data. So just a sanity check that they are generating the data for the frequency that we're expecting, and that they're generating the amount of data that we expect, so the field of view is not compromised. That is one. And then the second one is we call it like a positioning quality indicator, which is a compound information between our sensor fusion, a combination between the registration quality, the information of the GNSS, and how long it has been running. And we kind of give you that as an output for you to operate as accordingly. So that's kind of the second level of information quality we have.
And then the fleet manager is constantly monitoring the fleet. So if there are any faults or issues or errors, that all gets reported up centrally through the fleet manager. And I noticed one of the questions in the chat was, can you do remote video monitoring? So yes, you can put a camera, just an inexpensive camera on the machine, and that video feed can be sent up through to the fleet manager, and you can view that through a web portal or the fleet manager interface.
Then there was another question regarding the information that you need from the vehicle. Okay, so what kind of information from the machine is needed for the navigation software to work? I mean, is scan signals, odometer? What do you need there?
In terms of information from the machine, we need odometry at least, so some sort of velocity information coming from the vehicle. Could be encoder, it could come from motor controller itself. And then, of course, to control the machine, you need to have an interface. Well, we have an interface definition that you need to comply with in order to be able to drive the machine at certain speed forwards and turning with certain angular speed. But that's it. Then the other sensors, they need IMU, and GNSS is recommended.
One general question, but I guess I ask you, Jose, just to give the answer very open, because there are a lot of questions that are saying, what are the limits in terms of fog, rain, sun, snow, etc.? What are the limits? I mean, in my opinion, I guess it depends on the sensor itself rather than the software. But please explain this, because there are a lot of questions. So with your answer, we close this topic.
Yeah. So we can then later, to anybody that would like, send you the function specification. In that one, we describe what's the level of visibility that you need, and what's the level of fog and snow that it can cope with. But again, it's a bit sensor specific, so that function specification is for kind of the best sensor that we can provide.
So that is the point. The point in that case about fog, rain, snow, etc., is more the sensor is the bottleneck, not the software that is managing the information. Yeah,
the snow is a bit the software, because we can kind of filter out the amount of snow that's coming in. So it's kind of a dynamic objects that we are filtering out. So we see, okay, it's noise. We're just worried about mostly static objects, and we want to register and compare with regards to that. And that's what we do. Now, if you accumulate a lot of snow, then you need to kind of highlight that, okay, this needs to be cleaning after this session or something like that. But we have seen differences between different LiDARs, how they cope with the fog. If it's a dense fog, some of the best LiDARs can see up to 10 meters, and that might allow you to drive. And you can also tune the noise level by just kind of do some filter based on intensity in those cases.
Okay. I think we have finished just 5 minutes late. That's fine. There are more questions in the chat, but then all these questions we will forward it to you, and you can then answer one by one, okay? Because they are more specific, so we could stay here all night long. For you, Peter, is all the day, but we have to go home now. And so, well, okay, there are the contacts there, good. But in any case, in the email after the webinar, you will receive this information. I'm talking to the attendees now. So, well, I don't know if there are other questions or not. Otherwise, just to say you thank you, Jose, Peter. Very, very interesting about this topic, because I think it's, as I said, is a new, relatively new and a challenging topic that is coming more and more to our industry, and it's great to see that there are solutions here to solve all these challenges that we've seen about the outdoor. Okay, so if you want to add something else, Jose, Peter, feel free.
Nope. Thank you so much for hosting this, Alfredo. This was great.
Okay. Same for me. Thank you very much. Thanks, everybody.
Thank you, everybody. So look for the email, because you will receive more information. The slides are in the email, and also more information about the combined solution about Navitec and GIM Robotics. Okay. So thank you, everybody, as usual, for being here and for supporting these initiatives. Bye bye.
Bye bye.
Bye bye.